Now we'll start to cover the problems in fundamental principle of counting. So I'll strongly encourage you to actually solve the problems before seeing the solutions, which I'll obviously cover, so that you actually understand the concepts better. Here is the first problem. Find the number of four-letter words with or without meaning which can be formed out of the letters of the word rose where the repetition of the letters is allowed. So let us think about this problem first, and I'll give you the choices which you'll actually use. So we have four letters actually in rows, right? They are R, O, S, and E. So we have to find the number of four-letter words which can come from these four letters. So the idea to think about it, I'll give you a hint, is basically to think of each of the letters as a separate box which you have to fill with the choices available to you. So the choices are 1, 240, 256, 64, and 24. So the correct answer is 256. So let us see why this is the case. So like I said, we start with the fact that we have these four options: R, O, S, and E. Now, let us consider only one block. For example, you just have to fill this particular block with one of these four options. So, in how many ways can you actually do it? Four, right? Because you have four options, so you can either use R, O, S, or E to fill in this box. So you have four options here, right? So the question is to actually make four-letter words. So I have four boxes like this. So what will happen for the second box? In how many ways can I fill the second box? Recall carefully in the question, repetition of letters is allowed. So that means that if R, O, S, or E fill in the first box, then they can also fill in the second box. So again, this box also will have four choices, right? R, O, S, and E, and this also can be filled in four ways. And you can see the pattern here. Even the third box can be filled in four ways because you can repeat the alphabets, right? And similarly, the fourth box. So now we know independently that each box can be filled in four particular ways, right? So there now lies the fundamental principle of counting. So if we want to see these four events happening together, how do we actually know in how many ways can you do it? So in the fundamental principle of counting, I had explained to you that the events, if we call the event, say, I will call it event I, event 2, event 3, and event 4. So each of these boxes, filling these boxes, is one event. So now we have to find event 1, 2, 3, and 4 together. The number of ways in which these events happen together, right? So in fundamental principle of counting, what we do is that we multiply the number of occurrences for event 1, event 2, event 3, and event 4, right? We started with just an example of two events, but I had explained to you that we can extend it to more than two events. So we have all the numbers required for this. The number of ways in which the event 1 can happen is 4. Event 2 can happen is again 4, right? So you have 4 again. And event 3 is again 4 and 4, right? So this is basically 256. So this is the correct answer. I hope you understood the application of fundamental principle of counting here. The key point is to divide this into 4 separate events and see how many possible ways each event can be actually done. And then you can multiply each of these events to get the answer. Let us look at another problem which is very similar. So again, we want to find the number of 4-letter words with or without meaning, which can be formed out of the letters of the word rose. But here the key point is that the repetition of the letters is not allowed, right? So this is the key difference between the two questions. So now I would encourage you to think about this question, and we have the following choices: 24, 32, 256 and 240. So take a minute and think about this question and try to solve it, because we already solved a very similar problem, but just take into account the fact that the repetition of the letters is not allowed in this case. The correct answer is 24. Let us see why. Again, I have 4 boxes, right, corresponding to 4 letters of the word which I have to form. But now there are some key differences. What is the key difference? Let us start with the first word, this first box. Okay, so in how many ways can you actually fill the first box? So we have these 4 letters, right? R, O, S and E. So all 4 of them can be used for the first box, right? So the first place can be used by R, O, S or E, right? So what happens here for the second box? In how many ways can you actually fill this? What do you think? So if actually I use one out of these 4 alphabets to go here, one is gone, then how many letters are left to fill this? How many alphabets, I must say, not letters, but you have 3, right? If I choose R as the first letter, then I only have to pick between O, S and E. Similarly, if I pick O, then I'm left only with R, S and E. So no matter what you pick, you are left with 3 choices for the second box. So this is a very key point you have to understand. So here I have 3 letters. What about the third box? Third box, you follow the similar principle. 2 out of these 4 letters have been used, right? So 1 goes here, and then 2 out of these are used after the second box. So how many are remaining for this? You have 4 minus 2, right? So you have 2 left. And then for the last box, you already used 3 of the letters, and you are not allowed to use any of the letters twice. That is the key difference between this and the previous question. So you are left with 1, so, right? So it's like 4, then 4 minus 1 is 3, then 3 minus 1 is 2, and 2 minus 1 is 1. So what is the answer? Again, like I said, you have to now apply the fundamental principle of counting, and I won't go through the detail again, because you understand that the event which we are looking for is the event of making 4-letter words, right, without repetition. So what is the answer? Like I said, the first box can be done in 4 ways, the second box can be filled in 3 ways, the third box in 2 ways, and the last box in 1 way. So we already have this answer now, because using the fundamental principle of counting again, So we have all these separate events, like I called them event 1, 2, 3 and 4 before. So you have to follow the similar procedure. This will come naturally to you as you practice more problems. So you have 4 multiplied by 3 multiplied by 2 and 1. So this answer is 24, right? In this particular case, it doesn't matter whether you begin with fill in the first box and then the second box and the third box. You can actually start backward or even from the middle. For example, I can start from the fourth box first and see that there are 4 choices for the fourth box and 3 choices to fill the third box because I used one of those letters for the fourth box, and 2 choices for the second box and 1 choice for the first box. And still you can see that the answer is same. You multiply the same numbers and get 24. So in some cases it does matter which box you fill in first, but not in this problem. So I'll cover another kind of problem in the next section where this order will matter.